This is the 37th video on rigid body kinematics. This is in continuation of the 36th video. So in this video we will discuss the concept of instantaneous axis of rotation, okay, its location, okay. Before going ahead, I will tell you again then that if you go through these videos and it's complete, you don't have to go anywhere else. And if you understand these videos fully, then you can take a problem from any source, you will be able to solve most of them. In case you have some difficulty, you can put that doubt in the comment box. I'll look into it, okay. And all the videos of these rigid body kinematics have been put in the playlist. You can see those videos, all the videos there, okay. So in the 36th video, I discussed regarding the location of the instantaneous center of rotation. So several methods were mentioned. First was by mere observation, which has already been discussed, okay. So now we'll take up the location of IC by different methods, okay. So location of IC by different methods we'll take up. So location of IC by different methods. Location of IC by different methods, this will take up, okay, fine. So before going ahead, one thing I would like to just restate it, that this is the frame of reference F. This is a rotating rigid body M in plane motion with respect to F. Suppose this is the IC of M with respect to F at time t. This is the IC of M with respect to F at time t. This is some of the point P in the same base plane as the IC. This is the vector R. Suppose sense of rotation of omega of M with respect to F is clockwise, and velocity of VPF will be written as omega cross R. And magnitude of VPF is just the speed of VPF, speed of P with respect to F, which is simply omega R, because omega and R are right angles, and VPF is at right angles to this line vector R. Magnitude of VPF is equal to omega R, and direction of VPF is normal to this line joining IC and point P, corresponding to sense of omega. So this result I'll use frequently, so I'm mentioning it here. So IC of M is at a distance of R equal to VPF by omega from P. So IC of M is at a distance of VPF by omega from P along the direction omega cross VPF. So IC of M is at a distance of VPF by omega from point P along the direction omega cross VPF. So this fundamental result needs to be remembered, okay. So IC of M is at a distance of VPF by omega from P along the direction of omega cross VPF. So IC is at a distance of VPF by omega from point P along the direction of omega cross VPF, okay. This result will be used very frequently, and this is called IC concept. The point which is at distance R from IC, its speed of this point will be omega R, and its direction will be right angle to line joining IC and P, corresponding to sense of omega. This result will be used frequently, so I mentioned it here. Alright, fine. So now I'll take up different methods. So I'll write down the question. A rigid rod A1 A2 of length L rotates in a vertical plane with respect to ground as shown. In each case, locate the IC of rod with respect to ground at the given instant by different methods. Okay. This era bit, okay. Length L of the rod is given to be 2 meter. Okay. By several methods. Okay. So I'll write down the question part A. So in all cases, F is the ground frame. F frame means ground frame. And M frame we have the rod, rigid body. This is the ground frame. This is the rod A1, A2. Length of rod is given to be 2 meter. Velocity of A2 is given to be 12 meter per second at right angles. And velocity of A1 is given to be 2 meter per second at right angles. Okay. Now we have to locate the IC of the rod with respect to ground at the given instant. So now IC of the rod has to be located by different methods. Okay. Now in this case, we have to tell where the IC of the rod is going to be. Alright, fine. Now see, IC of the rod is at IC of rod has by definition has a zero velocity with respect to ground at this given instant. Now velocity of A2 is rightward 12 meter per second. Velocity of A1 is 2 meter per second rightward. They are both in the same direction. So in this case, IC of the rod cannot lie on the rod. See, one thing I would like to say in this case, omega of rod in this case with respect to ground will have a clockwise sense. This is 12, this is 2, so it will rotate clockwise. Alright, so let us take we take a point P on this rod somewhere here, okay, at y distance below point A2. We apply SRC for velocity between A2 and P. SP arrow A2, OP arrow P. I give the velocity of A2 to P. This is P. I give 12 meter per second. P moves in a clockwise circle with A2 as center. I give omega y. The velocity of P becomes 12 minus omega y. Okay, fine. Now see, IC cannot be, IC of the rod, IC of rod cannot be on this line segment. IC of rod cannot be on this line segment A1, A2 because velocity of A2 and A1 are in same direction. Velocity of A2 and A1 are in same direction. This cannot be here because if IC lies here, then all the points above P will move rightward and all the points below P will move leftward. But this point is moving rightward, so IC cannot be here. So IC should be somewhere below this point, below A1. See, this is 12, this is decreased to 2, but direction is same. So 0 velocity point should be somewhere here. Okay, fine. This error bit, okay. So IC will lie somewhere below A1. Is it clear? Because if IC lies somewhere here, then all points above P should move rightward and all points below P should move leftward. But this point is moving rightward. So IC cannot be on this line segment. It should be somewhere below A1. Why not above A2? Because if this is IC above point A2, then the rod will begin to rotate anti-clockwise, which is not possible because omega is clockwise. So IC should be somewhere below A1. Okay. So IC is somewhere here. So I'll draw the diagram again. This is A1, this is A2. IC is somewhere here. Suppose distance of IC from A1 is Y1. Okay. Now we can determine A1, Y1. Now Y1 can be determined by several different methods. First method is C. A1 is at a distance of Y1 from AC. The velocity of A1 will be omega Y1 by IC concept. And velocity of A1 is how much? 2. So omega Y1 is equal to 2. Now what is the distance of A2 from IC? That is equal to 2 meter plus Y1. So distance of A2 from IC is Y1 plus 2. The velocity of A2 becomes omega into Y1 plus 2. Omega into Y1 plus 2. That becomes how much? 12. Now if you divide these two equations, omega goes away. Omega into Y1 plus 2 by omega Y1 becomes 12 by 2 becomes 6. Omega omega cancels out. Y1 plus 2 becomes 6Y1. So 5Y1 barabar 2 meter. So Y1 is equal to 2 by 5 meter. This is therefore the required answer. Okay. So distance IC is at a distance of 2 by 5 meters below point A1. Okay. This was the method one method. So there is another method also. Another method is this, and 2 is this. What we do, we find omega. Omega of this rod with respect to ground is relative normal speed by separation. Omega of this rod with respect to ground is relative normal speed by separation. Now normal speed of A2 is 12 rightward and that of A1 is 2 rightward. Both are in same direction. So from theory of relative velocity between 2 points, relative normal velocity between A2 and A1 will be 12 minus 2. By separation is how much? 2 meter. So this becomes 10 by 2, that is equal to how much? 5 radian per second clockwise. This is the angular speed of rod with respect to ground. Okay, fine. So now we use the IC concept. IC is at a distance of y below point A1. So 2 is equal to omega y1. 2 is equal to 5y1. So y1 is equal to 2 by 5 meter. Is therefore the required answer by method 2. So in method 2, what there is advantage that we don't have to write two equations. Only writing one equation of any one of these two and using the formula of omega, we get direct. This is another method of finding the location of IC. Okay, fine. So one method was that I wrote down two equations. Omega y1 is equal to 2, omega y1 plus 2 is equal to 12. And then dividing these two and solving, we get y1 equal to 2 by 5 meter. Another method was that we first find the omega from relative normal speed by separation and then use any of these two equations to solve it. I use this equation plus the value of omega. I can do that also. Omega I can determine and use this one to solve y1. Both will get the same answer. Okay. Now we can solve this by method 3 also. So this we can solve by method 3 also. Method 3 is first what we do, we take A1, A2, any one of them. Now IC is at a distance of VA1 by omega from A1 along the direction omega cross VA1. Okay. Now first what we do, to determine this distance we need omega. Omega we find we calculate as we did in method 2. Omega is equal to relative normal speed by separation. 12 minus 2 by 2, that is 5 radian per second. Clockwise, that is omega. 5 radian per second clockwise, that is omega. So, and velocity of A1 is 2 meter per second. So, IC is at a distance of VA1 by omega, that is 2 by 5 meter from A1. In which direction? Along the direction of the vector omega cross VA1. Now see, omega in this case has a clockwise sense. So, direction of omega from right hand thumb rule is cross, normally into the plane of board. And VA1 is rightward. So, omega cross VA1 is where? Omega is this way, VA1 is that way. Omega cross VA1 is downward. So IC is at a distance of 2 by 5 meter vertically below A1, which is the same answer as you obtained by method 1 and method 2. Okay, so this also we have obtained the value of location in IC. Actually, instead of using VA1, we can use VA2 also. We can say this also we can say. So this was method 3. Method 4 is this. IC is at a distance of VA2 by omega from A2 along the direction of omega cross VA2. Okay. Now what is omega? Omega is 5 radian per second. So VA2 by omega is how much? VA2 is how much? 12. 12 by 5, that is 2.4 radian, 2.4 meter. 2.4 meter from A2. Along which direction? Omega cross VA2. Now omega is clockwise, so omega direction is inward. VA2 is rightward. Omega cross VA2 is downward. So 2.54 meter below A2. That is 4.4 meter below A1. So same answer again we have obtained. Okay. So this problem was solved by 4 different methods, which I fully explained. But initially I said that IC cannot be in this portion. Because if IC is somewhere between this, then all points above P will move rightward, and all points below P will move leftward. But this point is below P1, A1, that is moving rightward. So IC cannot be in between this. IC also cannot be above A2. Because if IC is above A2, then rod will move anti-clockwise, but it is rotating clockwise. So only location is that IC of the rod should lie below A1. IC of the rod should lie below A1. Alright. So IC is at a distance of VA2 by omega from A2 along the direction of omega cross VA2. That is 2.4 meter below A2. That is 0.4 meter below A1, which is same as we obtained by the remaining 3 methods. Alright. This side a bit, okay. Now I take another question. See, this is the ground frame, frame F. F is ground, M is rod frame as usual. This is the rod A1, A2. Length of the rod is 2 meter. Length of rod is how much? 2 meter. 2 meter is the rod length. Velocity of A2 is 16 meter per second rightward. And velocity of A1 is 4 meter per second rightward. Okay, fine. Now in this case again we have to locate the IC of this rod with respect to ground by several different methods. Okay. So again by method 1. Now in this case, where will the IC lie? See, this point is moving rightward and this point is moving leftward. So there should be a point on the rod lying between the points A1 and A2 where velocity of that point should be 0 with respect to ground. By definition that is the IC. Is it clear? This point is moving rightward and this point is moving leftward. So there should be a point somewhere lying on this rod A1, A2 whose velocity with respect to ground should be 0. So that all points above this point, all the points of rod above this point move rightward and all the points of rod below this point move leftward. So by definition this is the IC of the rod. So in this case IC of the rod will lie somewhere between A1 and A2. Alright, IC of the rod will lie somewhere between A1 and A2. Okay, now we have to determine the location of IC by various methods. So I'll let the IC be at a distance of say y1 from A1. Now what is the omega of this rod will be in clockwise sense because this is moving rightward, this is going leftward, so rod will rotate clockwise. So now method 1 is this. A1 is at a distance of y1 from IC. Velocity of A1 is 4, that is equal to omega y1. A2 is at a distance of 2 minus y1 from IC. So speed of A2 is how much? 16. That is omega into how much? 2 minus y1. Okay. Now if you divide these two, 16 by 4, 16 by 4 equal to omega into 2 minus y1 by omega y1. Omega omega cancels out. So this becomes 2 by y1 minus 1. So 16 by 4 is 4. So 2 by y1 is 5. So y1 is equal to 2 by 5 meter. So in this case, IC is at a distance of 2 by 5 meter above point A1. This was a method 1. Okay. So I'll drop this one. Okay. One thing I would like to repeat, why IC lies between A1 and A2, I suppose it is clear. Because if you take any point on this rod, say at a distance of say r from A1, then velocity of this point will be a continuous function of r. Is it alright? So at upper point r is 0, then velocity is rightward, and at lower end r is equal to 2 meter, velocity is leftward. Since it is a continuous function of r, so velocity should be 0 somewhere between these 2 points. So IC should lie somewhere between A1 and A2. This I have already explained it. Alright. Now what I do, method 2. Method 2, what I do, that I don't write two equations, I write simply one equation. First I determine omega. Omega becomes relative normal speed by separation. Normal speed of A2 is 16 meter per second rightward, and that of A1 is 4 meter per second leftward. So omega becomes relative normal speed by separation. They are in opposite directions. So from theory of relative velocity between 2 points, relative speed becomes 16 plus 4 upon length of rod is how much? 2. So 20 by 2, that is equal to 10 radian per second. And sense of this is again clockwise. Why clockwise? Because A2 is going rightward, A1 is going leftward. So omega has a clockwise sense. Now I take any A2 or A1. A1 is at a distance of I1 from IC. The velocity of A1 is how much? 4. That is omega y1. That is equal to 10 into y1. So y1 becomes 4 by 10 meter. That is equal to 2 by 5 meter. Same answer as you obtained by method 1. Same answer as you obtained by what? Method 1. Alright. So y1 is equal to 2 by 5 meter. That is therefore the required answer. Alright. Now we can solve another method also. If we IC is at a distance of VA1 by omega from A1 along the direction omega cross VA1. Okay. Now what is the distance VA1 by omega? VA1 is how much? VA1 is 4. Omega we have calculated how much? Method 2 by omega we have calculated omega is how much? 10. 4 by 10. 2 by 5 meter from A1. Along which direction? Omega cross VA1. Now omega is what? Clockwise. Omega has a clockwise sense. Direction of omega is cross into the plane of the board, and VA1 is left. So omega is into, VA1 is left. Omega cross VA1 is by right hand rule, it is cross product rule, it is upward. So it is 2 by 5 meter above A1. So same answer has been obtained by method 3 also. Now we solve this by method 4. Method 4 is this concept. Instead of A1 we use A2. IC is at a distance of VA2 by omega from A2 along the direction omega cross VA2. Okay, along the direction of what? Omega cross VA2. Alright. So IC is at a distance of VA2 by omega from A2 along the direction of omega cross VA2. Now see, VA2 is where? Rightward. Omega is what? Inward. So VA2 is rightward, omega is inward. Why is omega inward? Because sense of omega is clockwise. So omega is into the plane of the board. VA2 is rightward, omega cross VA2 is downward. So what is this value VA2 by omega? VA2 is 16. Omega is how much? Omega is equal to 10. So 16 by 10 becomes 1.6 meter. 1.6 meter vertically below A2. That is 0.5 meter from 4.4 meter from A1. The same answer we have obtained again. So all those 4 methods I demonstrated this problem. Alright, fine. So this side of it. I'll take another problem based on this similar problem. This is the rod A1, A2. Okay. Length of rod is given to be 2 meter. Velocity of A2 is rightward, leftward, say 20 meter per second. Velocity of A1 is rightward, that is say 4 meter per second. Both the velocities are with respect to ground. Now again we have to locate the IC of this rod A1, A2 with respect to ground by different methods. So method 1. Now first of all note that in this case A2 is moving leftward and A1 is moving rightward. If you take any point P on this rod, say at a distance of say y from A2, then velocity of point P will be a continuous function of y. Now when y is 0, that is P is A2, velocity is leftward, and when y is this 2 meter, that is P is A1, it is Va1 is right, 4 meter per second. Since Vp is a linear function of y, therefore there should be a value of y lying between 0 to 2 meter such that velocity of that point is 0. So that point by definition is the IC of the rod. So let us this distance be denoted by say y2. Okay. So in this case IC of rod will lie somewhere between A1 and A2. Say here I suppose. Okay. Now method 1 what I do. Now A2 is at a distance of y2 from IC. So 20 is equal to omega y2 IC concept. And A1 is at a distance of 2 minus y2 from P. So velocity of this is 4. Omega into 2 minus what? Y2. Now what I do, I divide these two. 20 by 4 becomes 5. Omega cancels out. Y2 by 2 minus Y2. So this becomes 10 minus 5 Y2 barabar Y2. So 10 barabar 6 Y2. Y2 becomes 5 by 3 meter. That is one answer. 5 by 3 meter below P. 5 by 3 meter below A2, sorry. 5 by 3 meter below point A2. That is the IC of the rod with respect to ground by method 1. Okay. Now method 2. In method 1 what I did, I wrote down two equations. First for A1, other for A2. Now method 2 what I do, I first determine omega. Omega I determine using that formula omega is equal to relative normal speed by separation. Now normal speed of A2 is 20 left and that of A1 is 4 right. Both are in opposite directions. From theory of relative velocity between 2 points, relative normal speed between A1 and A2 will be 20 plus 4 upon separation is how much? 2 meter. This becomes 24 by 2. That becomes 12 radian per second. Now one thing note that sense of omega in this case is anti-clockwise. This is going rightward, this is going leftward. So rod will rotate anti-clockwise. So sense of omega is anti-clockwise. Now this side of it, okay. Now we take any of the 2 points. Velocity of A2 is at a distance y2 from IC. So VA2 will be written as omega y2. Now VA2 is how much? 20. 20 is equal to omega. Omega is how much? 12 into y2. Okay. So y2 becomes how much? 20 by 12, 5 by 3 meter. That is the required answer by method 2. Now method 3 what we do? Method 3 we apply this formula. IC of rod is at a distance of VA2 by omega from A2 along the direction omega cross VA2, along the direction omega cross VA2, along the direction which one? Omega cross VA2. Now what is this VA2 by omega? VA2 is how much? 20. Omega is how much? 12. So 20 by 12 is simply 5 by 3 meter. In which direction? Omega cross VA2. Now omega is what? Anti-clockwise sense. The direction omega is dot. Now it is normally out of plane of board. And VA2 is leftward. So omega is this way. VA2 is this. Omega cross VA2 is downward. So 5 by 3 meter vertically below point A2. Which is same as we obtained by method 1 and method 2. So 5 by 3 meter below point A2. So this we have obtained by method 3. Okay. This we have obtained by which method? Method 3. Alright. Then finally we come to method 4. Method 4, what we do, IC of rod is at a distance of VA1 by omega along which direction? Along the direction omega cross VA1. Now first we evaluate this distance VA1 by omega. VA1 is how much? 4. Omega is how much? 12. This becomes 1 by 3 meter. 1 by 3 meter from where? A1. That is at what distance from A2? A2 it becomes 2 minus 1 by 3. That is 5 by 3 meter. Now 1 by 3 meter from A1. Along which direction? Omega cross VA1. Now VA1 is right side. Omega is this side. Omega cross VA1 is upward. So 1 by 3 meter vertically below A1. 1 by 3 meter vertically above A1. Sorry, not below A1. 1 by 3 meter vertically above A1. That is 5 by 3 meter vertically below A2. So same method we have obtained by method 4 also. Okay. Fine. Alright. So this also I'll grab it now. So this was the 37th video on rigid body kinematics. Okay. So in this I took up several problems. Fine. So in next video also I'll take a similar problem on IC location. Okay. So this you go through it properly. If you have any doubt, you write in the comment box. I'll look into it. Okay. And all the videos of this chapters have been put in the rigid body kinematics playlist. You can go and see it. Okay. So this I close it here. Okay. Fine. All right.